Good afternoon, everyone, and welcome to today's live astronomy show from the Science Museum of Virginia. My name is Justin. I'm one of the astronomers here at the museum, and as always, I'm happy to be your guide for today's show. If you've watched some of our previous episodes, welcome back. Always good to see familiar faces connected to the show. If you're just joining us for the first time, that's all right. You don't have to have watched previous episodes to enjoy today's show. If you do want to catch up, they're all saved right here on Facebook for you. You can catch up on YouTube as well. And I'll go ahead and put it at the front of the show. This is a strange one to join the series on. This is going to be our last show for a little bit. We're going to take a little break as we get into the summer months and things are starting to pick up here in the buildings. We want to be able to focus on your experience right here in the dome as well. That said, we've got a fun show planned for today. So a couple of things to keep in mind. If you have questions or comments during the show, feel free to leave those down below. And if you got questions, I will do my best to answer them during the show. We also need to thank our sponsors for today's show, Allianz Partners. Great to have them on board. Thank you for enabling programs like this here at the museum. For today's show, we're going to be using software similar to what we use in the theater at the museum. It's called Digistar 7. It's planetarium software that can do some pretty cool stuff. So if you're able to, I recommend watching this show full screen on the biggest monitor you have. I think those are all of the rules. So with that, let's get started with the show. I've got a few updates for you, some things I'm keeping an eye on that I thought you might like as well. Let's get switched over to the Digistar view, and we are going to start with a little update from Mars. It's been featured a lot during our shows. It's been in the news a lot lately. Of course, Mars is home to a couple of new robots. 3 different missions arrived here at the Red Planet back in February. I've been updating you regularly on the Perseverance mission, and also its little hitchhiker, the Ingenuity helicopter. I just saw today that the Ingenuity helicopter completed its 6th flight on Mars. This was the most ambitious yet, and as a result, things didn't go exactly as planned. The helicopter is safe, I'll tell you that up front, but in these real images from the helicopter, you can kind of tell that it was wobbling a little bit. It wasn't flying straight and stable, but luckily the engineers that worked on the helicopter here on Earth had planned for some issues like this, and so the helicopter was able to get through it, land at its 3rd different airfield here on Mars, continuing its extended mission. What I really want to update you on today, though, is the newest resident of the surface of Mars. It was one of the missions that arrived here in February. It was China's first mission to Mars. Part of the Tianwen-1 mission is the Zhurong rover, and that rover has now landed on Mars. I'm going to try and find its landing site. Looks like it's currently nighttime there. But we'll just zoom in here a little bit, kind of stationed between the current location of the Perseverance rover on your left, Curiosity and Insight, a couple of older robots to your right. But there's the nighttime part of Mars where Zhurong is located now. But we do have some pictures from this rover. China is now just the 2nd country to operate a rover on Mars, so a pretty elite club there, and be exciting to see what the rover does. It's equipped with some unique instruments, although I guess both Perseverance and Zhurong have some ground-penetrating radar they'll be able to use to probe beneath the surface of Mars, and it's a slightly different terrain that is tough to see in the dark, but may be able to explore what was once an ancient ocean shore at Zhurong's location. So Perseverance exploring what may have once been a lake, Zhurong perhaps at the edge of an old ocean. It used to be in Mars's northern hemisphere. So pretty exciting. Always great to have a new rover on another planet. Speaking of places where there have been rovers, well, humans drove rovers around on the moon 50 years ago. I just saw that a couple of companies are teaming up to build a new rover for the Artemis astronauts when they get to the moon. But today's real moon story is what happened a couple of days ago. You may have seen in the news that there was a lunar eclipse. We didn't talk a whole lot about it here leading up to it just because it wasn't visible for us here in Richmond. The total part of the eclipse took place after the moon had set on Wednesday morning. So we weren't able to see this view. When we have a chance to see a total lunar eclipse here in Richmond again, I highly recommend it. But I brought you here today because of what you may have seen in the news leading up to Wednesday's eclipse. If you read any news coverage of this total lunar eclipse, you probably saw something like that strange mix of words that are on your screen now. Super flower blood moon. It may surprise you to know that we don't often sit around the office here talking to each other about super flower blood moons and things like that. First, just kind of a mouthful. They've given me this soapbox, and nobody is here to stop me. So I'm not a big fan of these kinds of names. It kind of describes what's going on. It generates a lot of attention when you see things like this in the news, but it's not the most accurate way to describe what's going on, at least in my opinion. Let's break it down. Let's go word by word. I'm going to drop out the easiest word to get rid of here, blood. Why is it called a blood moon? Well, during a lunar eclipse like this, the moon can take on kind of an orange or red color. Blood certainly not involved. It's just because of, the way sunlight travels through Earth's atmosphere. The same reason that sunsets can look orange or pink or red. Different colors of light are just scattered differently by the molecules in Earth's atmosphere. And as a result, the shadow that our planet casts into space takes on that kind of reddish or orange color. And during a lunar eclipse, the moon just moves through that shadow, so it takes on that reddish or orange color. My real beef with this, though, is that the phrase blood moon comes from a prediction of the end of the world that gained a little bit of traction about 8 years ago. There were some books published, plenty of websites, I'm sure. And I'll admit that things haven't been going great the last few years, but we are still here. The world did not end. The prophecy was wrong. So I think we can ignore blood moons. Okay, so now we've got super flower moon. You may have just heard super moon before. What is a super moon all about? A super moon is just when the moon takes off its glasses and fights crime. No, a supermoon is what some people call the moon when it's a little closer to the Earth than usual. The moon's orbit around the Earth is not a perfect circle. The red circle there is perfectly round. The gray line that goes around the Earth is the orbit of the moon. So you can see they don't perfectly match. And on Wednesday, yes, the moon was near perigee. That's its closest point to the Earth. So it was a little bit closer to our planet. And when the moon is a little bit closer to the Earth, it's going to look a little bit bigger in our sky. So let's see how that looks. I've got the moon there for you. I believe this is how it looks at perigee. I'm going to put a label on there for you. So perigee is the point closest to the Earth. Apogee is the point farthest away from the Earth. And there are some pretty obvious differences there. Perigee does look much bigger. So the moon will look a little bit bigger and brighter in the sky. But I don't really think that it looks that super at perigee. One big problem is the moon does not look like this in the night sky. The moon is, it's pretty far away all of the time, and so it looks pretty small in the sky. Depending on what kind of screen you're watching this on, this may be accurately scaled or maybe a little too small, but you kind of get the idea. I'm still switching between apogee and perigee, so that is not a supermoon. That was a supermoon just before it. And then there's another problem. We see one full moon, then it's not a full moon for a month, and then it's full again. So I faded things out so you couldn't see what was going on, and I stopped the clock. Quick, are you looking at a supermoon or not? It's kind of hard to tell. It's so small on your screen. It is, but it may not have looked that spectacular to you. The big problem for me is that, again, the phrase supermoon, not the best origin story. It's been inherited from astrology, and well, aside from the tides being a little bit higher when the moon's at perigee, the position of the moon in its orbit doesn't really have much effect on our lives. So I'm going to get rid of that too. Now we're left with flower moon. I guess flower moon isn't a terrible name. It's kind of nice. It does kind of harken back to the days before we had organized calendars, agreed upon months that were certain lengths. People all around the world would use the moon to help them track time. And of course, if you counted the number of full moons you had seen in the sky, you kind of break the year up into maybe 12 or 13 different segments. And it would be a useful thing to do to give each one of those moon cycles a name, like we've named our months now. So I don't have anything against flower moon specifically. That's just the name that whoever wrote the Old Farmer's Almanac latched onto a couple hundred years ago. So it's a fine name to use. I just think that you do miss a little bit of the variety and the diversity of cultures that perhaps your family came from or might exist in your area. Different indigenous peoples around North America and even some cultures around Europe would name the moon different things at different times of year. It was like their names of the month that we use today. So I think if everybody uses the name flower moon, you're just missing out on something. So I guess call the moon whatever you want. It's just the moon to me. I'm going to call every other chunk of rock and ice that goes around some other planet a moon. And I mean, if you can inspire the names of hundreds of other objects, that's pretty good in my book. So there you go, the moon. Let's see, something else that I want to talk about today, some exoplanets, and also more of my favorite things. Now, I've covered exoplanets in lots of these other shows. We visited some of my favorite spacecraft, like the TESS spacecraft here. If you've watched previous episodes, you may have even seen the multicolored bands that like to stretch across the sky, the thousands upon thousands of stars that TESS is monitoring for signals of exoplanets, these planets orbiting other stars. One of my other favorite things is to get requests from my audiences during our shows. So if you haven't done it yet, put something in the comments. Let's look at something interesting during today's show. But during our live shows here at the museum, every once in a while, we'll hear some request that don't instantly have the right answer for. And I don't mind being stumped once, but I don't like being stumped twice. So I was pretty happy a couple of months ago when somebody came to see a show and they asked me a question I couldn't answer that day. Somebody asked, what is the biggest exoplanet? A lot of astronomers working on missions like TESS are very excited to find small planets, rocky planets like the Earth that perhaps have habitable environments like the Earth does. So, maybe looking for the biggest exoplanet isn't the top of some people's mind. But it was for one of our guests here at the museum. I don't remember what I told them that day, but I now do know exactly which planet is the largest one that we have found out there. And it depends on how you think of largest. Certainly you can think of the physical size of the planet. The largest planet we have found by diameter is one that goes by the rather romantic name GQ Lupi b. It's about 3 times the diameter of Jupiter. But there's another way to think about largest. An important measure of the size of an object in space is its mass. Not so much its physical size, but just how much stuff is there, how many atoms and molecules. And the most massive known exoplanet is physically a bit smaller, but it is a couple dozen times the mass of Jupiter. So there's a lot more stuff there. It's just packed more densely together. So there you go. I've got that answer at the tip of my tongue now. And giant planets have also been in the news a little bit recently. There was a study that was just published in the last couple of weeks that looked at where these giant planets are found in different planetary systems. If you're familiar with our solar system, you know, we've got the sun there at the center, then we've got smaller rocky planets, and then gas giants farther away. And these astronomers were curious with where giant planets are found in other planetary systems. So over the last 30 years, they've been monitoring hundreds of stars, trying to understand the planets that are in orbit around them and how large their orbits are. They managed to identify just shy of 200 giant planets going around their target stars. And so here I've transported those giant planets into our solar system. And many of the orbits are kind of small. They're pretty close to the sun here, but there's a decent number that are farther away. And astronomers also know that when we search for planets like with spacecraft like TESS, we're not going to see every single planet out there. And our techniques tend to make it easier for us to find planets close to stars a little farther away, or a little tougher to find them farther away. So we found this many planets that are far from their stars, and we know that we are missing a certain fraction of all of the planets that are out there. We can extrapolate from that, and we can say that well, it looks like the zone where it's most common for a gas giant planet to exist extends from about 1 astronomical unit, or the Earth's distance from the sun, out to about 10 astronomical units. And if you're familiar with the arrangement of planets in our solar system, that's exactly where Jupiter and Saturn are. The largest planets in our solar system are also where we think the largest planets in other planetary systems are most likely to be. So I've made some comparisons between our solar system and other systems in the past. Ours looks kind of unusual, but this new study shows that at least in one regard, our solar system is typical. It's what we would expect of the way the universe works. So that's always a good thing to discover, that the universe is going about its business exactly the way it should. Let's see, I've got a couple of quick things for you before we wrap up. We are getting ready for the summer, so I wanted to set you up with a couple of things to keep in mind for the next couple of months. Summer is always a good time to watch some big blockbuster movie, and it's always been a fun thing that we do in our shows here from time to time, usually our special events, to look at some space movie, see how it does in terms of accuracy and science. So just for our virtual audience here, I have decided to review a space movie during today's show. It's a recent release streaming, so you can watch it at home. No need to head to a crowded theater if you don't want to. It's called Stowaway. And the basic idea of Stowaway is there's a mission to Mars. You've got your crew on the way to Mars, but as the name suggests, there's a stowaway, an unexpected person on the spacecraft. I'm not going to ruin the story for you, so no spoilers. Don't worry about that. The movie did a few things really well, as science movies usually do. The good things in Stowaway include the spaceship that they are taking to Mars. It's kind of hard to see in the screenshot, but the crew module's at one end of a long tether and they rotate it. They give themselves artificial gravity. They're doing a variety of scientific experiments on the mission, including growing plants. You can use those for food once you get to Mars. You can use those to help generate oxygen in your spacecraft. That's pretty good. And they wore spacesuits when they went outside. It's kind of low-hanging fruit, but it is something they did well. Didn't do everything well, though. There are some bad points in the movie. I'll start with the very first scene. They're launching to start their mission to Mars. They're wearing these orange launch and reentry suits that real astronauts wear. But one thing you always hear the astronauts do before they launch is to close their visors. The astronauts have their visors open. They eventually have to close them, but I guess it's harder to see the actors' faces with the visors closed. The worst thing about the movie, though, I've got to say, this is the stowaway himself. And for somebody that wasn't expecting to go on a mission to Mars, he had a pretty far-ranging wardrobe. I counted at least 6 different shirts that he wore during the course of the movie. So pretty amazing that somebody that was not supposed to be in the spacecraft had a fully stocked wardrobe. Let's not giving anything away, but there you go. A few good and bad things to watch for in Stowaway if you choose to watch it. Pretty interesting flick. Take a look if you're into space movies. One more thing I thought I could do for you before summer starts is let you know a couple of neat things to keep an eye on in the summertime skies. One is revisiting an old subject from one of our previous shows. One will be something new. So here we are outside in Richmond. This is a nice summer night. We're facing generally south. And in the southern skies here in Richmond in the summer, one constellation that you might be able to recognize is Scorpius. It's shaped kind of like a scorpion. You might be able to see it front and center on the screen here, kind of a curved line of stars that you might be able to imagine the shape of a scorpion's tail there. I want to show you one particular star here, though. It's just out in front of Scorpius. I'm going to put a little marker on it along with some fancy pictures of the sky so we can zoom in on them and see this star. It is marked there, and I'm going to get a closer look at it. This is a star that I talked about a few episodes back. We talked about how astronomers figure out how old things are in the universe, and this star stood out because of its age. Astronomers might call it HD 140283, but it rose to fame because it looked like the oldest star that we had seen anywhere in the galaxy. By studying it carefully, both its motion through the galaxy and the elements present in its outer layers, astronomers estimated that it was about 14.5 billion years old, which was a little problem because that's older than the entire universe is. There's some big error bars there, so it works out. But thanks to some new measurements, we can now refine this age, and it looks like it's a little bit younger than we thought at first, now estimated to be about 12 billion years old. Still pretty old, still certainly one of the oldest stars that we are aware of, but at least now it's younger than the universe, so that takes care of a little bit of confusion that may have been out there. So that's still really old star, is in the sky. It's a little bit too faint to see without a telescope, but not too tough to locate out in front of Scorpius. Another interesting star to look for in the summer. Let's look up along the Milky Way here, the other stars in our galaxy. There are 3 bright ones that rise high overhead by midsummer. They form a famous little asterism, a little collection of stars called the summer triangles. The 3 brightest stars on your sky there. They represent the summer triangle. And I want to zoom in on one particular star here. It's kind of along one of the long edges of the triangle. It's a star named Alberio. And let's just zoom in on it here. Now Alberio doesn't look all that special if you don't have binoculars or a telescope. But it's an easy target if you do have a little telescope, and it will reveal something interesting. Alberio is not just one star. There are at least two stars here. And if you do look at it through a telescope, maybe a little tough to see on the screen here, but it's pretty striking that those two stars are very different in color. One of them is noticeably more orange or red. The other is noticeably more blue, which is pretty cool. Certainly talked about star colors before, and love to have you in the dome, do a whole show about it someday. It's just kind of a neat thing to see with your own eyes. Two stars so close together with different colors. That's been a little bit of a mystery for astronomers to solve, whether those two stars just happen to line up in our sky. Maybe one is much, much, much farther away, but they just happen to line up for us here on Earth, or if they really are associated with each other. Do they orbit around each other? Is it actually a binary star system? Well, now we think we have the answer. And there are a few more oddities that were revealed about this system. So let's go take a closer look at the Alberio star system to wrap up today's show. We can now estimate that it is a little over 300 light years away from us, and it appears those two stars we can see in our sky are not especially close together, so that they're probably not orbiting around each other. Even stranger still, we think the one that looks red in our sky is actually two stars on its own. So the red one, it's tough for telescopes here on Earth to tell them apart. We can analyze how the stars are moving and pick up that there must be another star hidden there. So it's actually at least three stars. But wait, there's more. Let's get this red star closer to us. Astronomers call this Alberio A, and then there's a little companion here called Alberio AC. Names in astronomy are always confusing. But astronomers analyzed how this system was behaving. It looked like there must be a little bit of extra mass there they couldn't see. Remember, mass is a very important feature of objects in space. And so it may be that Alberio AC is actually two stars on its own. But that causes some other problems. So it's also possible that this other hidden mass comes in the form of something that we can't easily see. It could be a black hole. So if you can find Alberio in the summertime skies, point a telescope at it, you'll see two stars. But know that it's at least three stars. It might be four stars, and it could even have a black hole, which is always pretty neat. You won't see the black hole for yourself, but I can show you the effects of what it might look like if you did fly right next to it. You see the gravitational lensing from this small concentration of mass. And then there's one other little tidbit that I'll throw in here. Since we don't think that the orange star we can see and the blue star we can see in telescopes are actually orbiting around each other, now we wonder how they got so close to each other in the galaxy. Why do they seem to kind of be moving through the galaxy together? Well, it looks like there may be a few more stars in this general neighborhood, at least four others. None of these are orbiting around each other like we saw in Alberio A, but just know that little pocket of space in the galaxy holds at least, well, there's six I can see here, then maybe two others. So anytime you look at the night sky, just know there's more than meets the eye there. There's always new things to find and discover. So until I'm back with you for another virtual show, I hope you are able to get out, see some of the wonders of the night sky here in these summertime months. I hope you can join us here in the museum soon. Come to the Dome, see one of our live shows here. But until then, I just want to thank you for watching today's show. If you've watched all of these episodes, I want to thank you for joining us for the series. Keep an eye on our social media. May return for some shows in the not too distant future. Always exciting things happening. Who knows what will inspire our next show? I hope to see you for that show. And until then, stay safe out there, and I will see you next time.